Hello, this is Sihan, and my second milestone was to connect my camera to my NanoNet guppy model. And as you can see here, I have a bit of code which basically captures an image, saves that image, and plugs that image into the API code that NanoNet provides for your model. So this is the NanoNet API call that they provide, and I just copy this into my code, and all I have to do here is capture and save an image and put that here. Okay, so back to my code. In order to capture and save an image, I wanted to use some functions from OpenCV, which is a library that has a lot of stuff for object detection. And actually I ran into an issue when using CV2. I got this error message, and I couldn't figure out why, because I had installed OpenCV and CV2, the packages, on my laptop, but for some reason the system couldn't detect them. So as an alternative, I just did all my coding on my Raspberry Pi. That solved all my issues with this. So as a walkthrough through this code, here I kind of open my Raspberry Pi camera. This line is part of, this is calling to my NanoNet model, and then we enter a while loop in which each loop represents capturing and processing one image that the camera takes. So first we we take a picture and we save it to this variable, and we name this picture. We add this picture to our API. These three lines are all part of the NanoNet's provided API call. And response is basically the prediction that the model makes based on this image that you sent. It's given in the format of a JSON response, which is just a structured file with, in my case, prediction specs. So here are some of the things that you could find in a JSON file: the score, accuracy, and then these four are the coordinates for the bounding box of what the model detected. And what I could do in the future is play around with these numbers and do something. So after this is finished, this kind of just displays the image that we just took onto the monitor that Raspberry Pi is connected to. And if I want to stop my code, I can press G, and I will break out of the while loop and end the code for real. Or I could wait 10 seconds and we will loop through this code again and take another image and process another image. I wanted to test my model on my real guppy fish, so I had taken a video of them and had my camera take pictures off of the video, which is displayed on my phone. Yeah, the lighting was kind of weird, so maybe that's why this photo turned out really dark and blurry. So I wanted to move to the actual tank where there's natural lighting to get a better photo. And so here are the results. One of the problems that I've noticed, and I think I mentioned this in my first milestone too, is that my model seems to think that a lot of things are guppies because, like, I don't know, the shape looks similar when in reality they're not. And I think part of the reason why this is happening is because I'm using rectangular bounding boxes in my model, and so it's not as accurate as if I were to use masking, which is basically another type of object detection where instead of a rectangular box you could have an outline of the actual thing they're trying to detect. NanoNets only uses rectangular bounding boxes in their object detection model, so perhaps I could try using TensorFlow or OpenCV in the future to create a masked object detection model.